So let's switch back to our scene that we were working on, and let's work on some metal materials now, just so we can see how metal behaves. All right, so all right, there's that. Let's see how this goes. And I'm going to switch back to main simple inorganic materials if this will work. If not, like I said, I took some screenshots of some of the stuff that is worthy of figuring out. It still says what? Okay, good. There we go. All right, so we're going to pick up where we left off with the Zen Garden scene. Very simple scene. So far, this looks like it's working. And let's go to aluminium. All right, so the index of refraction, at least for the page that I'm using, I've got experimental. It looks like it's Raykick, 1995. I'm not going to switch between too many of these, only because I'm tempting the fates of the internet gods. And I'm afraid that we're going to lose the connection altogether. So I'm going to go with what's here. What's that? Oh, yeah. Definitely. Big time. So refractive index, extinction coefficient. Let's figure out how we're going to apply this to our materials. All right, first off, let's get reference, if we can, for some aluminum materials. Aluminium. Aluminium is the correct technical term for it. It's only the Americanized version that's aluminum. All right, so yeah, we done gooder. Okay, so reference. There we go. At this point, I'm almost tempted to use my phone as a internet source. Yes? All right, wait, here we go. One second. One second. Yep, no, we're going to go with white metal. So this will serve good enough right here. What I'm basically looking for, I pretty much know it's going to be white metal. It's going to look kind of like most other white metals. What I'm looking for is that bit of roughness that's going to be inherent in that material, no matter how polished it is. Because if you polish a piece of aluminum and you polish a piece of silver and you polish a piece of chrome, they're going to look completely different. It's going to be the type of light that's being reflected back and the level of roughness and the makeup of the materials inside. So this is kind of what I was after. This will work fine. And actually these sheets right here will work pretty well as far as reflectivity. So what I'm going to do, yes?
In terms of reference, or at least for this, okay, usually what kind of reference do you look for? Like, you look for something like, oh, I'm thinking about strong lights, or I'm thinking highlights, or soft.
Well, good question. And Frank's actually going to get into that today for Project 5, like the reference you should be looking for your project. For this, I'm looking for something that is in an open environment and shows me a lot of reflectivity. That's kind of why I chose this, because I can see the environment in it I mean, ideally, it'd be nice to be able to see more of the environment to figure out whether it's totally enclosed or maybe it's sitting outside somewhere. And that's usually what I'm looking for. Now, here's one of the caveats that you run into is I like this image as far as an environment goes because I can see what kind of reflections I have. It may not necessarily be a good image if I wanted to, for example, suppose this was brass or copper, something I wanted to sample the color for. That might not be a good place to sample color for. I might want to have something with this kind of matrix background.
Right.
Now, the downside is this matrixy background with solid white doesn't show you what kind of environment's in. It doesn't show you where the light source is coming from. It's not really valid to use as a light source. But it is good as a secondary reference for color. If you just want a sample of color and because it's pure. And I'm going to show you that in a second. So that's a good question now. What kind of environment is it in? So here's another one. This is kind of a warehouse, lots of light. This is another one. Yeah, I'm going to go back with the original, this one right here. That works pretty good. All right, so as far as what I'm going to do to make this, first thing is I'm going to switch from artistic to physical. The first thing I'm going to do is make sure my edge color is all the way up. Because the amount of metal reflectivity I get is going to be based off of the index of, or the refraction index and the extinction coefficient. One other thing I do with metal, and you're going to do with metal and glass, is take the gain and turn it off. We do not want any diffuse bleeding into the metal. Metal is all about pure reflectivity. Now, I am going to take the roughness down to the default of 0.2. All right, so here we go. This is what we're going to get our setting. So the first number here, the refractive index, is 1.1978. That number gets plugged into the refraction index right here. All the numbers get plugged into the value. We're not adding any color, any hue, or any saturation. It's going to be 1.197. So, refraction index 1.197. And you'll notice you only have 3 digits. It looks pretty dim, but we did take our value above 1, which is okay. Maya is a 32-bit or 32 floating point program, which means we have all those numbers and energy that we can grab. All right, so 1.197, the extinction coefficient is going to be 7.048. That gets plugged in down here in the same place, 7.048, down under value. Notice that it turns that little speck highlight in my sample super bright. Yep. So, let's render this out and see what happens. In theory, it should look sort of like our reference.
So regardless of artistic and physical, the edge color is going to go all the way up each time.
Well, yeah, if you want to look at it like that. The only caveat's going to be is we're going to make brass later, and brass is where we are going to plug our red-orange color into, in the edge color.
So for metals, the colors come from the edge color.
Correct.
Because there's no diffuse.
Correct. It's all reflectivity in metal. It either bounces light or it absorbs light. All right, here, let's take a look at my level of reflectivity. That's kind of why I wanted this reference here. looks like I've got a little more roughness than I need. So I'm going to knock this down to, let's try and it might be, maybe I knock it 1.15. What I'm looking at here, I'm not looking at this highlight here, I'm kind of looking at the reflection. Go ahead, you have a question? All right, anybody have a question so far? Does that make sense? That's your roughness. And your refraction index, check your value, should be 1.197. Yep. And your extinction coefficient should be 7.048.
Okay, there we go. I just have to remember this stuff. I have another way around. Okay.
Right, level of roughness, remember, for metal, it's all about the numbers, and then you manually are going to have to figure out how rough it is. This is going to give you the right amount of reflectivity and the right look for the metal, the amount of whiteness, but it's not necessarily going to give you the rough. It's not going to give you the roughness, that's for sure. Then knock the roughness down a little, or increase the roughness, I should say. So mine might even still be a little rougher based on what I have here. So, yep. Once you get the refraction index, extinction coefficient, it's all just about the roughness.
And the color.
Right, but for most metals, they're white metals. That's why our edge color is white. All right. Did I lose anybody? You got it? Good. All right. Does that make sense? Yes. Okay. Shoot. Okay.
Primary speculative.
Correct. You changed to physical, right?
Yeah.
Okay, make sure your gain in the diffuse is 0. Edge color should be turned all the way up at 1. This is primary specular. Correct. Turn it, just basically take your slider, crank it all the way up. Refraction index, click on the color swatch. Down in the value, you are going to plug in 1.197. The only thing we plug in there is value information. And then down in the extinction coefficient, right under it is 7.048. Now it's up to you to adjust the level of roughness. The default is 0.2. Render that out and you should get results that are fairly similar to mine. Okay. So I'm going to stop my IPR. And so, aluminium, if you will. Let's go and choose another. Now let's. Yeah, white gold's really kind of platinum-y.
Oh, actually, another question that I have to do. You have
Well, because that would be a transparent and refractive object because light goes through it. That's glass. Yeah, we're sticking to just metal right now. Let's do chromium. Yes.
Just like a small question that I was wondering is that metal changes color with temperature as well, when the blackness, the swords and stuff. So I was
Correct.
wondering if the index of reflectiveness changes when the metal goes through such.
Yes, I believe it does. But you would need to find if if you're trying to do an animation based on that. First of all, you'd be doing a simulation, not just guessing an
Right.
animation. So you would have to go find numbers of the metal you're going to work with measured at different temperatures, the refractive index of it. So the refractive index and the extinction coefficient, yes, will change because the metal's undergoing stress of some type. In this case, it happens to be heat. So, and a lot of times when they forge metal, it'll be a base metal which may be very brittle, which may reflect differently than a metal that's hardened, where it's been heated, cooled, cooled to kind of condense all the molecules a little more.
Yeah.
So it's going to reflect a little different. All right, let's do same sphere, same level of roughness. The only thing we're going to change is the refraction index and the extinction coefficient. All right, so chromium, which is kind of a shiny whitish, it's a shiny whitish metal. So 3.212 is going to be your refraction index. 3.212. A lot more energy right away in that reflectivity. And the extinction coefficient is going to be in the threes also. That's going to be 3.30. 3.30. So just changing those two numbers, let's render it out and compare how it looks next to the aluminum.
And what was the number for the refraction?
3. Refraction index? That's going to be 3.212.
Okay.
And then you got the extinction coefficient? All right, so just changing those two numbers changes how the metal appears. A little more, almost blue, because it's reflecting a little more of that environment. Not quite as whitish looking. And that white's coming from, that extra bit of white is coming from the higher extinction coefficient number and the lower refraction index number. All right, so I'm going to stop that. And two more we're going to do. I'm going to go down under other miscellaneous materials and let's go with alloys. Let's go permalloy, which is kind of a nickel iron. All right, so refraction index is 2.229. I'll freeze the screen so you guys can have those numbers. So you plug 2.229 into refraction index value, extinction coefficient. It's going to get 3.755. This is called permalloy, which is kind of like a nickel iron alloy. And I got permalloy under the, oh, you can't even read that. It's under other miscellaneous materials under alloys. Okay, 2.229, 3.755, and going to re-render. All right, little bit brighter than chromium. Not as bright or as white as aluminum. But again, it's all about the reflectivity. That's really everything we look at in metal, it's all about reflectivity. Question. Does that make sense? All right, I'm going to stop this. All right, let's take this material, this alloy, and let's turn this into an anisotropic material. All right, now, so we're going to turn this into a brushed metal look. All right, so I'm going to start my IPR, but there's no guarantee it's going to keep up because IPR hates this part. Under Advanced, under the primary specular, go down under Advanced, you'll see anisotropy. First thing you want to do is take your anisotropy and drag it up to 1. Now you'll notice it looks like my sun kind of disappeared. It became like a couple of pixels in a smeared line. So that is basically changing the direction of how the roughness is. Right now the roughness goes vertically. To 1, correct. Now, the other recipe for doing brushed metal is roughness. So the default level of roughness starts to add a little bit of realism to it. Now, 0.2, probably not enough. So what I'm looking for is a reflection that kind of looks a little bit like my bottle here. That sun should be a pretty decent size streak. So I'm going to bump up the roughness a little more. Well, the direction is the anisotropy. So at 1, it stretches vertically as though you had horizontal brush strokes, which is what's going on here. They take it, they brush it horizontally. Now, most of the brushed metal that you'll see in full sail is brushed horizontally, like our door. Take a look at the door jamb at the bottom, the door handle. A couple of the soap dispensers in the bathrooms are vertical brush strokes, and consequently the highlight stretches side to side. Yes?
Well, I've noticed that like the higher the reference goes, the more warp it starts to look.
Yes. And that's another property of brushed metal. So all the reflections are going to be stretched, distorted, and really, really soft. Now, does that give me enough of a bloom for my light? Maybe not. This is where I like to switch over for brushed metal from the specular mode of Beckman, which is the default, to GGX. And you'll notice that just that little bit of extra softness in the GGX sometimes will make a huge difference in how my highlight stretches. In this case, it kind of makes it go from pole to pole. Now, might be a little on the rough side. Let me knock it down to 0.35. So this is Beckman, and this is GGX. GGX, again, just a little bit softer. Now, the sun in my image is fairly small. If I threw another light in there, like an average light, like a spotlight that had some size to it, a rectangle light, something that had some physical size, my streak would get a lot bigger. Does that make sense? So it's all about reference. You have reference for brushed metal. How which direction does it stretch? If it's a vertical stretch, you're going to be taking your anisotropy to 1. If it's stretched horizontally, you're going to take it to -1. Those are the differences. And then how rough is it? Start at the default of 0.2, work your way up. Or down. But most of the time, brushed metal, if it's got streaks in it, it's at least going to be this rough. All right, questions? Yes.
When I'm using my render, it's not showing my report, but it's not showing the vertical highlights.
You have roughness on?
Yes, my roughness is at
0.7, too much. 0.7, that's almost total roughness. Tried knocking it down to 0.3.
Is that 0.3?
You might need to stop IPR and run it again. Yeah, never trust IPR.
Once it starts like doing stuff and then but it doesn't look like it's changing anything.
Yeah.
And then we restart.
Yep, exactly.
He doesn't have a specular light.
All right, so first off, do you have the right numbers plugged in for the
You
material?
can't change it between Batman
He doesn't have a specular mode option.
Are you down under primary specular?
Yeah.
Are you on our picture or physical?
You got to be in physical.
I believe,
Oh, you're in the wrong event.
you mean normal times? Yeah, right.
Yeah,
There you go.
Yes. Well, the line is the sun. That is actually your streak. Like I said, the sun is really tiny in the picture.
Oh, there we go.
So, and that is actually this light right here. It's the distant light. So remember, it's meant to be infinitely far away. If I,
Oh, there we go, I got it. I forgot to set mine to DTS.
well, here's what you could do. You could just take a disc light or a rectangle light, replace it, and then you'll have a physically bigger looking light, and it should give you more of a highlight like this. All right, let me go back here. Let's stop IPR. Let's go back again. All right, let's take a rectangle light. That's why I made one. And I'm going to hide the sun. Let's make this light a little bigger. And let me turn the roughness off. Anisotropy off for now. Yep, too much. Just a little. Heh. Don't trust IPR. Yeah. That's because it's the future. Everything's made out of chrome in the future. All right.
And I don't know when they look somewhere in like somewhere lower that's
All right, so now I've got a big shape on there. And let's see what happens when I add anisotropy. First thing I'm going to do, turn up my anisotropy all the way. All right, so turn that up all the way and then start 0.2. Point 3. All right, so looks all broken up, but what I'm going to do is stop the render, do a little region, and render at a higher resolution, like 128. Because with low levels of samples, it's not going to fill in the highlight area. That kind of makes sense? So it's based on the shape and the size of your light source. Now, like I said, the sun with that default distant light that I had, that's going to be like a pinhead. So you're not going to get much in the way of stretching. That's why most of the time photographers will use big light shapes, so they can get that shape to show up in the reference. Well, mesh light would be good if you just want shape. Yeah. All right, questions? All right, one last thing that I wanted to show you guys was, in case anybody was interested, let me see, I do have a bookmark for the camera view. There we go, good. Is making brass, because brass is usually a very popular item, especially for the exterior. A lot of times people like those brass candle holders. Even though they're LED candles, it doesn't mean that the bases can't be actual metal instead of plastic. So what I'm going to do is just reset my material right now to the default. Roughness of 0.2, going to take off anisotropy, zero it out, that stops it. Change back to Beckman because it's a little sharper highlight. And let's look up brass. Right there. And there we go. All right, so notice, refractive index, really pretty low. Extinction coefficient, not that high either. First off, let's find out, what does brass look like? We are staying on physical. Remember, anything metal, physical. Anything metal. So if you have a doubt, use this as your guide. Yes? Interior and the exterior. Either, it depends on which one you did day or night. But both of them, yes.
Seems how in a normal, like, everyday household, no one's
depends on what you're referencing.
I mean, like,
If it's brushed metal or nickel, you can make that with this. If
Yeah,
it's got
I-
roughness to it, you can make it. But go ahead.
Yeah, I'm just saying like gold, like gold colored metal, it's not actually gold. It looks like gold. So, but what we're doing, it doesn't matter if it's actually made out of it, it's just that it's.
Yeah. So a lot of times they will have, I know what you're getting at, it'll be gold plated.
yeah.
Okay? The exterior part of it is going to behave a little bit like gold, but if any light gets through it, it's going to behave like the base metal, which is probably going to be aluminum or some other alloy. Start with what you see, and if you don't get the results, then go with what you know, or what you can find out about the object. But most of the time, you can nail it pretty good just by going, that's metal, it's yellow, it's probably this. Yeah, and that's what we're going to be doing here is basically just trying to get as close as we can to the original. So here's brass. So and actually, what I want to actually look up is brass candle holders. Yeah, brass knuckles. That's what I want to look up. All right. Actually, I don't need brass candle holders. Let's just find something, say an object that looks pretty cool for brass. Something like that's not bad. That's got a lot of etching in it, a lot of stamping. That's going to have a lot of roughness, just because of all that stamping and all the work in it. Same thing here. Now this right around here, that's not bad. That's pretty smooth. Yes.
How would you know the difference between making smooth or it having just so much light that you can't see? There are some cases where if I like put a lot of light on it and it overexposed.
It will overexpose it. Well, what I'm trying to do to make the material from scratch is find something that's not overexposed or underexposed, that's fairly neutral, that displays the material, and I'm going to just see how I can make it and get it to look good outside. Now, if I'm doing this as part of my project, then I'm going to want to see what does brass look like outside in direct sunlight or inside in man-made light. Right now, we're just doing this as an exercise to try and get that brass look. So let's see. Let's go back to. That's not bad. That works pretty good. Let's see if we can use that. All right. So first thing we're going to do, let's plug in our refraction index and extinction coefficient. So I'm going to freeze this. So the refraction index is 0.361. We're still in physical. 0.361. Pretty low. All right, the extinction coefficient, 2.821. 2.821. Roughness, going to keep it the same. I restored the specular model to Beckman. I turned off anisotropy. Again, diffuse is off. There it is. Right here. There we go. All right, now, based on my reference, it looks a little too rough. Here's the part that's going to hopefully make it brass. And that is getting color from in the edge color. Oh, sorry. Yeah. Thank you. Wow. All right, so over here. There we go. All right, so I turned the roughness down because 0.2 was way too rough. What I'm trying to do is match about the level of roughness here. That may even be a little much, but the next part is I've got the right refraction index, the right extinction coefficient plugged in. Now it's up to the edge color for me to be able to define how this looks. All right, so what I'm going to try to do is sample my color, and you guys can do this. All you do is click once on the edge color, grab the eyedropper, and bring it over, and you can sample the colors. I'm going to try and sample it in a not too bright area or too dark, kind of a neutral area right around here. See what that looks like. I'm going to restart my IPR. And I'm going to adjust my color based on what I see. That's going to give me a good starting point, but maybe not necessarily what I want. You could. But most of the time if you do that, you are getting somebody's interpretation of it. You'll find it either be CG or it'll be print, which is not really going to translate here. Just find reference and take your own sample from it. So that's actually not too bad. It looks pretty good. Now the inside's always going to look darker because there's a lot of shadow in it. And you can see, remember this is a multiplier. So the refraction index, extinction coefficient are what's giving us the brass look. The way the helix appears darker is the additive process. Remember, we add colors together, we add brightness together. So our colors are additive, making the helix look darker in the reflection. Does that make sense? So red metals, copper, brass, gold. What is it? Gold? Yeah, but it's still considered one of the red metals.
Oh, really?
Yeah. That's still going to go into the edge color.
Yeah.
Questions? Depends on what the object is. If it's metal, there is no diffuse. Remember that. Everything is reflectivity. If it's anything other than metal, there's going to be diffuse in the color. Everybody hear that? Does that make sense?
Sorry.
Metal, there's no diffuse. You're going to find that's going to be the same thing with glass when we get to glass. Because glass has its own subsection. It's basically physical glass, but they have their own controls for it. So it behaves a lot like metal. Anything other than metal is going to have some kind of diffuse in it. It's going to be color. It's also going to have some kind of reflectivity in it. Whether it's a large amount of reflectivity or not, that's determined on what your reference is, and also roughness. So for non-metal, it's going to be diffuse, that's color. It's going to be amount of reflectivity, that's face color, and then it's going to be roughness. For metal, it's going to be, most of the time it's white metal, so your edge color is going to be white. You're just going to plug in the refraction index numbers and the extinction coefficient numbers. And then dial your roughness in. If it's a red metal, like copper, brass, bronze, gold, all right, your color is going to go into edge color. Makes sense.
Mm.
So metal, edge color for red metals, everything else is white. For everything that's not metal, it's going to be diffuse color. Your edge color, face color is going to be white. Because your colors in your reflections are going to come from your environment and also from your diffuse. It's going to blend together. Questions? Okay. So, one of the common questions I get is, what about for the window outside for the external scene? So, if you look down in here, there's some guy in a window taking a picture. That is the kind of reflection you're going to have in your window for either daytime, exterior, or nighttime.
So it's a typical window.
Yeah, pretty much it's full sail glass. It's glass, but it's got a black backing on it, so it behaves like a mirror, but since it's got black, it's not really a mirror. The best way to make that is going to be something like we did here. So let's pretend that the floor is that glass down here.
You
Right.
go into artistic or
This is artistic.
artistic?
Yeah, because it's not metal.
Because it's not metal.
And it's not true glass because true glass is transparent.
Right, it's just an artistic interpretation.
Right, but an artistic interpretation based on reality.
Yeah.
So if you need this reference, go outside. Take your phone. Take a picture of yourself in the window taking a picture.
That's very nice.
Yeah, it is.
I mean, you could also use the screens on your phone as a reference. It gives them some kind of black
Yes,
reflection.
but I'd rather have you outside in light. Or do it at night. You know, if you did an exterior scene, next week we're going to be doing, no, not next week. Yeah, next week we're going to be doing a night class. So even coming out of lab, you can just hang out for about a half hour and wait for sunset. And then any of those windows that we're at in any of these buildings all have the same kind of glass. Right, so artistic mode, I'm just going to kick off IPR. First off, I'm going to make my backing, which is going to be my diffuse color, what? What's the reference say?
It has to be black. Well, not black.
Really dark gray.
Really, really dark gray.
Yes. So for that, it's going to be really dark gray. Now, what about edge color? Crank it up. Remember, it's all about reflectivity. 99% of the time, you can get away with cranking that all the way up. Now, as far as your face color, this is where you're going to start dialing in your reflections. Now, how rough is my glass? You know what? It's dirty. It's got some roughness in it, but it's not completely, like this. Yeah. It's not clean. So I'm going to knock it down. Maybe even a little more. So how does that translate? Well, let's rotate it 90 degrees and make it like our window. And stop IPR because IPR definitely was not happy with that.
IPR and mine are
Yeah, I think you've now you fully get it.
No, my
You understand. That's the reality of life. Right now, face color. If I crank it all the way up, probably too much. Right? Base it off your reference. If you're doing the daytime exterior, pretty simple. You can use the reference I have in FSO. But if you're doing it at night, just go out at night, see how dark it is. You're going to find it's going to be pretty dark, and you're going to be able to see lights in the reflection. You're not going to be able to make out as much detail. But of course, we have walkway lighting, so it's pretty bright. So they're still going to behave the same. Just remember, low levels of light mean desaturation because our eyes can't pick up. There's not enough light energy to pick up enough color. It's our rods that pick up most of the nighttime vision, so they are based on intensity more than they are on color. So that's why nighttime everything looks desaturated. But in reality, since RenderMan's trying to be physically accurate, even if you have a screaming bright red ball and you turn the lights down, it's going to automatically look desaturated because low levels of light, it's not going to be able to reflect as much. So if you build the materials the way they are for your reference, whether it's daytime or nighttime, they're still going to behave the same, just look different. So if you build brass candle holders, right, during the day, they're going to be nice and bright like this, but at night, it's going to be a whole lot different. Does that make sense? So at nighttime, for example, this might look like this, because we had a really low level of it's still too much. Right, pretend that's my moon. Notice that my brass, there's not a whole lot of light and stuff to reflect, but the objects are still there. And that is one bright moon, you are right. So let's moon eyes this. Still might even be a little bright. I could. The moon, it's actually warmer than you think. We always associate the moon with blue, but remember it's going through the atmosphere. It's still reflecting what? Sunlight, which is usually pretty warm. The color temperature of the sun. So we'll pretend that that's an okay moon. Yeah. Oh. All right. So nighttime, low levels of reflectivity, but you guys are going to have candles on the table. They're going to show up in your reflections. You're also going to have your moon that's in the actual HDR. Remember, if you positioned it right, your moon's going to show up in the window. Does that make sense? Mm-hmm. Now, as far as making brushed metal, inside in the interior, there's a thermos sitting on the table. That's brushed metal. Just like this. That's why I had you guys download the reference. I have reference for it. All right, the cap is going to sort of look like this. it's going to look just like my bottle here. It's going to have some reflectivity, but pretty low, very rough. Not the cap. There's a collar around between the cap and the body. So the cap and the body are the same brushed metal, but there's a little ring around the cap. Right, so anatomy of metal, right there. Questions? So today, you guys are probably going to spend a lot of time looking for reference. Believe it or not, that is the big part of the battle as far as now you guys have creative freedom over both your environments. What do you want them to look like? What are they made of? That's what you guys do. We're not supplying you with reference for any of that. Up until now, we've had you find your own reference to build simple lighting environments, simple lighting practices. Now, you're going to find reference for all the materials in your environment. So everything you're going to need reference for everything. Some reference images you're going to be able to find may cover more than one object. You may find, for example, let's utilize, a lot of you did probably the daytime interior, right? So if you're looking for reference for that, you could probably go inside living room day. And always go to tools, size, you want larger than 1K. Why? Because you'll find the perfect reference, but it'll be a postage stamp.
Yeah.
So you want to bypass anything. Now, what you want to look for is an environment similar to yours. It should have a window in it because you can tell where the light source is. And it should be daytime, because I said daytime, but that doesn't always mean that I get daytime when I get my search. So any of these might actually be decent reference. So for example, maybe you like the pillows here, but this is like uber clean. I feel like you got to shower just to walk in there. It's like one of those clean rooms they have at NASA. Yeah, the floor. This might be a good image for the floor. You might go, yeah, I like that floor. It's got a little bit of roughness to it, a little bit of reflectivity. You know, it's at the perfect angle with what I want. There's windows right there. I can see how the light's going to hit. So this you might tag for floor. And then you go, ooh, I hate the furniture. Okay, fine. So then you go searching for furniture. Well, long-term commitment, living with it, yeah, that's the same thing. The good side of this is it's furniture, you give it away if you don't like it. Unlike trying to get out of a relationship, you know, where it's like,
you don't have the money to buy new furniture, and then you sell it.
you know what, sometimes getting rid of the old furniture and living on the floor is a better option. Yeah?
If it doesn't match the environment of your apartment, you must get rid of it.
Sometimes it's just better to model it.
Now, see, that's the beauty of CG. You don't like it, you remodel it, or you rematerial it.
Yeah.
You're done. It's an easy relationship to fix.
College student where
No.
apartment furniture is good enough.
Unless your relationship
Where what?
with Maya is bad.
College students where apartment furniture, good enough.
Good enough, right?
As someone who's slept on the floor for
Yep. You don't like it? I have a towel I can put over that. There you go. Brand new coating.
new furniture.
Yep. I still do that.
Oh, I don't like this color on this couch. Black sheet.
Yep. Black sheet or towel. Go over to one of the fabric stores. Yeah, give me a big sheet of fabric. Just throw it over everything. You're done. All right.
It's the same couch. It's the same couch, but completely different. You just asked for the dog, you just put a seat on the different couch.
All right. So Maybe you like this environment. It's got sort of the same floor. Again, it's like Mr. Clean lives there.
With his magic erasers?
Yes, exactly. Now, here's something else you guys can do is when you're looking for a reference, you're not just stuck on the internet. There are plenty of furniture places around here. You know, anybody with a car, like going down Colonial, there's Rooms to Go, Cimarron's got a ton of furniture places. Right around the corner on Forsyth, isn't there some kind of freight furniture?
This
Also,
is
you can
Sears,
drop
like, on
Yes,
some,
Sears is another good one. Yeah.
either a catalog or an interior designs magazine. Never get rid of those.
Yes. Everybody hear that? Interior design. They get paid people to come up with color combinations and fabric designs. So they work with each other. That's a great place to start.
I don't know.
There is actually this really good, as a like GDC talk of an environment designer that says that he has an archive of just like, interior design, and he's just like, when you design an environment, design it like an interior designer would design it.
Exactly.
It's great. You can look it up. It's on YouTube. It's an hour and a half long thing.
Yep, I'm glad you brought that up. Think of your environment, think of the overall color palette of what your environment's going to be, just like you were working on canvas or you were working on a piece of traditional art. That is your canvas, is your environment. So color combinations, you definitely want to have some harmony in the air. If you want to have contrast, that's great. Just make sure it makes good artistic sense. I mean, we're not limiting you to anything other than if it's really repulsive, we're going to have a hard time grading it.
Gaudy.
Remember, we are artists before we are scientists.
Yeah, exactly. Yes.
I don't know if they do it out here too often, but you can find model homes that you're able to just walk
Yep.
in. Model homes are
Yep.
great.
What you guys can do is anywhere they've got a new development going up, or a lot of times apartments will have open houses and they'll have it fully furnished so you can go in and see. Take a camera. Yes.
Can I make that couch neon green?
If you have reference for it, yes, you can.
If I find a neon green couch.
All right, so how do you know? Let's see. Neon green sofa or couch, doesn't really matter.
Same thing.
There you go. I'm gonna have a hard time grading that.
Dollars.
Whoa.
You said one on the end?
Now, so this one would be terrible reference. Why?
Because it's a completely white background. It's like
Completely white background, you have no sense of what it looks like in an environment.
Yeah.
It probably, in an environment, I guarantee you it's not gonna hurt as much.
It's just a bad shade.
Just get all the dirt, Will.
That is lime green though. Okay.
That's lime green.
That's what it says right there. So this one is probably closer to what you might have in mind. And actually, that's not bad. I mean, because they've got pillows that match it. The floor goes with it. You've got the floor, the rug, everything kind of works with that green. Now, if you had orange floors and bright blue walls and screaming purple table, I think you're at the limit of taste right there, personally. Style, maybe, but taste, I don't know. Yeah. Yes.
just as a regular rule of thumb, I learned this as a painter. If you are using, for example, if you're using mostly warm colors, all your cool colors are supposed to be desaturated, or if they are saturated, they should be very few. So if you got a lot of oranges and yellows and reds, then your blues and your purples and your like greens should be either very, very desaturated or very few.
Right, but always based on reference, too.
Always based on reference, but
Yes.
that's your regular rule of thumb when it comes to dealing with the color.
All right, so if you have a wall like this, that's going to be tough.
Yeah?
That's tough. Could you imagine living with that all the time? You wake up in the morning, it's like,
Ah, my read just blinded me. Oh no, that's just my.
I'm awake, I don't need coffee.
My read just blinded me. Oh no, that's just my decor.
Okay, hey, it works. If you have reference and that's what you want to do, chances are though this looks really CG. So
And looks
Yeah.
very CG.
One other thing is try, if you suspect CG, it probably is. So find photo reference. Because you're only getting somebody's interpretation of what they did from probably a real photo. So get the real photo. Take your own photo reference if you can. And terrible picture. There you go.
Oh, yeah.
Turtles.
Yes. Turtles.
I think my.
I like Frank.
Your commenting.
I like
Again, this kind of reeks of CG. It's too clean, it's too pure, it's too perfect.
There's a tennis around the house and I need somebody who wants nothing but one color in their house.
Hello, my turtle.
Oh, no.
There's your warms and your cools. This is from the future.
We all live in
So
pods.
that makes more sense.
It looks like something right out of Ex Machina, right there.
Yeah.
No.
Here's a reference.
That couch says pure design. It doesn't say anything about function.
It just looks like one of the first off the shoe. It's face of the marble. It was just painted green.
Yep.
Exactly what it looked like.
No wonder everyone went crazy.
Yeah, it does.
They had to live with that.
How many references do you think we should get for one thing?
For what? One object?
Yeah, so say like the candles, like how many?
Which is basically.
As many as you think you need to be able to do the job. If you can find one in an environment and it works for color and amount of reflectivity and whatever you're trying to do with it, fine. If you can't find candles in your perfect environment, like you found an environment picture with everything you need except the candles, find candles in a separate image. 1, 2, 3, however many you need.
Should we separate in the folders for the printer or just for all the?
You're going to have folders. You're going to have a folder with your reference, and you're also going to put it in a collage above your render. All right, now, couple things to keep in mind. You guys are going to be submitting 2 Maya files, 2 Targa files, and a folder with reference in it. Now, when you guys get into doing your actual final renders and putting them in the template, we're not providing you with any template reference. This is where you're going to collage all your reference above the render. Scale it, move it around, overlap it. The whole idea is to give a quick overview of your environment, your inspiration, your reference that you used, and then underneath is your render. Then the folder is for separate full-size, full-res reference. That way, if we have a question based on your collage, we can open up the folder, look at the full-size image, and go, okay, yeah, I see that now. Does that make sense? Like I said, Frank is going to go over a lot of this too in lab because you could easily spend a whole 45 minutes just talking about reference easily. Right, questions? No?
Oh, actually, yeah.
Yes.
What about, what do you call those mirrors in like police stations and stuff, like two-way mirrors?
One-way mirror.
One-way mirror, yeah. Or like, if it has like a tint to it, like, sometimes you look at reflections, like how we did ours, and it's got like a yellow tint or orange tint or something
Mhm.
like that. Or, I guess to keep the sun out of the inside. How do you?
Tinted glass.
Yeah, it's going to be tinted glass. That's going to be glass. It's going to be as though the glass color
There's
is
like
going
a
to be
film on
different.
it, even if-
Well, the glass color is going to be different. Usually the glass itself, most automotive glass is greenish. usually in color because it's usually got a little bit of UV protection. It's meant to block all the rays out. Not all the rays, but most of the harmful ones.
Okay.
Yes.
So if we tinted the color of the glass, would the light that comes through that be also be tinted?
Yes, and that's automatic. When we get into glass on Tuesday, that's
Okay,
what
so
we're going
not
to talk
really
about.
worrying about it too much.
Yeah, today, just worry about reflective objects. Anything glass, we will get to on Tuesday. I break it up because we are going to be adding extra objects to the interior environment. The only thing in the interior right now that you can be assured is glass is the vase on the table. That's going to be clear glass. So if you want to start looking for colored glass reference, that's fine. You guys can go ahead and start doing that too. But we're going to save that for our whole glass discussion. And also the exterior scene, you've got a wine glass, you're going to have wine in the glass, you've got a bottle. They're all going to be built the same, not built, but the material is going to be made the same way. Because liquid is going to behave a lot like glass. Because light's going to get through it based on how transparent it is. Yes?
Will it actually be like a liquid type asset or just like a solid object that we're texturing to be like liquid?
Well, the volumetric shape is going to match the vessel that it's in. And that becomes a solid.
All right.
So the material, as long as it doesn't have walls, it maintains the whole. If you've got, say I take my sphere
Yep.
and I turn that into glass,
Yep.
that sphere becomes a solid glass object because the space inside the edges is treated like glass.
All right.
There's a way to make it so it's like an ornament, but in reality you would model with an interior wall and an exterior wall. They get glass and inside would be air.
Awesome.
Does that make sense?
Yep.
So that's what we're going to be doing. So inside our wine glass, the bottom of the wine glass is going to have a volumetric shape in it that's going to represent wine. The top is going to be air. So when you look through it, you're going to have a pretty clear shot through the glass part. But when it hits the wine, it's going to refract and bend and behave as though it's going through a solid liquid shape.
So literally the model, like the wine has an actual model as if it was frozen. Like
Yes.
In Maya.
Mhm.
And then you just apply.
Yes.
The,
You apply the material to it, you give it the correct properties, and then it behaves, when the rays go through it, it behaves just like real glass, real liquid.
now it would be a whole different story if I want to see wine pouring out of the bottle.
That's a simulation. That you talk to Ari about.
We'll be going, that'll be,
In fact, Ari's working on that right now for one of our animation things. No, she's not here now. But when she comes in, you can ask her about it.
we're doing some animation.
Animation at the very end, yeah. And she's got some fire and pyro animations, but we're working on getting a liquid simulation where you're going to pour out of an object and have it fill the glass. But that
Liquid's harder.
it takes a while to do. You got fluids, you have collisions, you have particles, you have a whole bunch of stuff going on at the same time. Yes? You are doing everything in your interior and exterior scene. First, I'll find reference for them. Everything that's not glass.
I'll just use less.
Now, you can start finding reference for glass, like if you know, I want that kind of wine bottle, I want this kind of wine, that's fine. But we're going to talk about glass on Tuesday. So just worry about everything that's not glass. One other thing, in the window in the interior, there's no shape in front of the window itself. There's no glass. It's glassless.
What's glassless? The wall behind it?
The window
Oh, the window.
in the interior. So you don't have to worry about making that glass or doing anything with it.
Oh, okay.
I just want to clear that up because a lot of people go, well, there's no shape there. I can't check it. Yes.
Sometimes, I guess, like, the frames would be metal, would we make that metal?
You're going to make it whatever your reference says. So if it's vinyl, if it's wood, if it's metal, whatever your reference says. Reference for everything. Pretend you're getting a blank slate. You're coming in and you go buy this stuff. You buy it, what's it made out of? Okay, so you bought a sofa made out of cheese. For one thing, when the sun hits it, you don't want to sit there where the sun hits it, or else you're going to start sinking into your cheese sofa.
That cheese will last past the time I buy it.
I was going to say, yeah, I'm a little hungry. You know, people are going to come on over. We're having a cheese day. You know, everybody comes over.
Cheese fondue.
Yep, cheese and wine. If you're going to sit down, please wear this rubber or this plastic wrapper on you so you don't bring any contaminants into my sofa. But
Wear a hairnet so your hair doesn't get.
exactly, yeah, we don't want hairs in the cheese. Yep, everybody gets a hairnet. Everybody gets gloves. Everybody gets little footy things,
The room is completely sealed, like 100%.
and it's refrigerated.
And it's
Quarantine.
refrigerated.
Yeah, it's 37 degrees all the time in there.
You get to wear Crocs.
Why do you have a cheese sofa? Because I can.
Yes.
Once I'm rich enough to have a refrigerated room, like, first things first, cheese sofa.
Wait, so the cheese stuff
Yes.
is on the floor?
And then all your everything else is sculpted out of ice.
Ooh. Oh,
So the sofa's made of cheese, it's on the floor.
It sounds like a place.
Sofa's made out of cheese. Yep.
It's on the floor.
It sounds like a place you find in.
That's right.
Disinfected room. Completely sterile room.
Yep. Completely sterile. There you go.
because,
If it's sterile, you can eat it.
you could still actually, because there is cheese in one of the photos
There's cheese in the exterior on the
on
table.
the table.
Yes.
You would use,
Reference. Everything's artistic except metal.
Does it matter what kind of cheese it is, or is that up to?
Ah, yes it does.
moldy cheese.
It has to be the round.
No.
No, here's why.
Oh, hey, gotta write this down.
Here's why. So, reference for cheese, right? Everybody always asks, I want to do Swiss cheese.
Yeah, no.
Yeah, I'm not,
Unless you model those holes, not going to work. It's going to look cartoony. It's going to look terrible. Because the holes and the lighting that's baked into the image or the photo is not going to match your lighting. Guaranteed. So you have to model the holes if you're going to do this. Swiss cheese is the only one I would say you really can't do. Small, like air bubble holes, like I think Munster or Cheddar's even got a few, but Gouda, Gouda's a soft cheese. Doesn't really have too many air holes. It does have a few air holes. Those might, something like this might be acceptable, 1 or 2 holes. But if you've got, let's see, yeah, that's not too bad. That would probably work, although that's a little iffy.
I guess you could say if it's something your eyes go straight to, probably.
And then it's not going to work, yeah. That's a good rule of thumb. If you can't take your eyes off it, then yeah.
Then it's delicious.
Yes. And feel free to go by reference.
Then bring it to class.
Yeah, share.
If it makes it home, then you've got reference.
Just no cutting it. No cutting cheese, yeah.
But
Shut up.
All right. Good questions. Any others?
How about for the chairs?
Chairs? For the interior or exterior?
Exterior.
Exterior. Those are actually like director's chairs. They are usually wood frames, canvas back, canvas seat.
I just need to see a whole lot.
Yeah, not actual directors, but that's what they call them. They're folding chairs. Usually canvas material because it's got to be sturdy, it's got to be durable, and usually they're outside, so it's got to be moisture resistant, mildew resistant usually, and in the wood. Now, does it have to be wood? Nope. If you've got reference for metal or plastic, that's fine.
But if I look at the director chairs, even though it doesn't look like that, I can use that, and then take like a reference.
Well, you want to find, director's chairs outside. There you go. There's a before and after picture. Outside. That's just showing you can re-canvas your own chair.
What if I find something like a pattern with that? I only pick one color out of the pattern?
Pick one color out of the pattern for now. When we get into texturing, if you choose to do that environment, then you will have to find a texture that's similar to your reference. Or you say, you know what, I don't like that after living with it for a week. I'm going to switch and find new reference. You can do that.
Okay, so right now we're just finding the colors for our.
Colors, reflectivity.
Okay, so then is it next week we're gonna be going to textures, or is it?
Next week on Thursday, we're going to start texturing.
Okay, so yeah, so we're mostly just focusing on the lighting and the colors and the reflection and reflective
Yep,
properties.
color, reflective property, roughness.
Okay. Okay.
Everything that's not metal. If it's metal, then, find the index of refraction or the refractive index and extinction coefficient.
Actual search, like you can just type in, on that website, the refractive index.
Well, the link is inside the activity.
Oh, no, I have it, but can you actually like do like a search in there for a specific?
I don't know. I've always just kind of hunt and peck.
Okay.
Now, here's something else you can do. If for some reason you're trying to find stainless steel, that is not in the refractive index. So normally if I have something like that I will just go in and type in and I don't want pictures, just tell me what it is. There we go. So a lot of times this will be some information that you can get. All you want is the high level stuff. Refractive index, extinction coefficient. Plug it in, see how it looks. If it doesn't look like your reference, it's probably either bogus numbers or your reference isn't what you think it is. But most of the time if you type it in, especially if most of this stuff is either a laboratory measuring it or it might be a company who manufactures the stuff. They have to publish these results for engineers. Because an engineer has to know what is the refractive index, what's the extinction coefficient, what's the conductivity of this metal. Make sense? Any other questions? All right. Good time for break. Go to dinner. We're back here in this room at 6 o'clock.